Hi, so this is the video for lesson 5 group problems for Sandra and Megan. Um, okay, so I'm going to be doing 1 through, I think it's 3, yeah. And then Sandra will be doing 4 through 5, and the link is going to be posted, her link is going to be posted in addition to mine on the discussion board. So, for number 1, it asks you about the allele arrangement in the heterozygous parent. And so it would be MG ARG over the wild type because it's heterozygous, and it would be crossed with a homozygous recessive, which is going to be MG ARG and MG-ARG. So you're going to be crossing this top one with this bottom one in it. Okay, so for B, it asks you to determine the gene order of these linked genes. And so to do that, you need to figure out, you need to look at your phenotypes and the number of offspring you have. And whatever your highest number of offspring is what's going to be your gene order for it. And so we determine the gene order by looking at the highest number of offspring, which we see is 76 and 69. And it's the, I'm not sure how to pronounce this, the agouti or Goody wild type mahogany and the wild type ragged wild type. And so that would look like this. So then this is going to be our gene order of the 3 linked genes. Okay, so next we're going to construct a linkage map showing the map distance between each of the 3 genes. So between the RG, the MG, and the A. And they're respective to the agouti, ragged, and mahogany. And so, to do this, you're going to take the smallest number of your offspring and you're going to add those to your offspring that was only crossed once. And so you can figure that out by taking each of the orders, and just swapping it once. So, for example, if I were to do this for the RG, it would be something like okay. So we would start out with something like this, and we would cross just one of them. Oh, except I think I crossed 2 by accident. No, I didn't. No, that was right. Sorry, that was right. I just crossed this guy here, and so I would be looking for that guy, and then I would do the same thing for the RJ. I would just flip those, and so I actually get for my numbers for those. It would be 1 plus 1 plus 76 plus 69. And you put that all over your total amount of offspring, which is 206, and you would multiply that by 100. So for the first one, the map unit that you get is 17.33 is what we got. And that would be between your RG and your MG. And then between your A and your RG, you're going to do the same thing. You're going to go ahead and swap out like the A's, and you're going to go ahead and find out that the relative phenotypes for that give off the offspring of 12 and 13. So you're going to add 12, 13, 1, and 1 all over your total number of offspring, which is 206, and you're going to multiply that by 100, and so you're going to get 13.10 mu. And so your map is going to look something like RG 14.3 to MG. something like that. So that would be your map. I'm sorry it's backwards. It's the best I can do right now. And so then you're going to have to calculate the interference, and to do that, you're just going to take your map units and you're going to put them over 100. You're going to multiply them by each other, and you're going to get a percent by multiplying that by 100 then. And then you're going to take that percent and you're going to multiply it by the total number of offspring, which is 206, and we just so happen to get 0.0227%. And so then the number we get off of that is 4.68. And so then we take that 4.68, and that's our estimated total. And then we're going to take the actual, which was only 2, because we take our 2, 1 plus 1. And that was from the agouti ragged wild type and the wild type mahogany. And we're going to go ahead and put 2 over that 4.68. And then we're going to go ahead and subtract it from 1. Or we're going to 1 subtracted by that number. And so it's going to give us 57.6%. So that gives us the calculated interference. So number 2 is the same exact thing. You're going to go through that same exact process. And so I'm just going to go ahead and name off the answers for them, since we kind of went over the first one. And for A, we're going to go ahead and have, for the gene arrangement of the 3 linked genes, it's going to be SC plus S and V, and then it's going to be over SC plus and V plus. And the pluses are dominant and they're the wild type. And so for B, the order of the 3 linked genes are going to be V, C plus, and S over V plus, SC, and C plus. For C, you're going to go ahead and do the same thing, the same process for the map distance. You're going to take your least amount of offspring, which was your 10 and your 14. And you're going to go ahead and calculate that. And you go ahead and you're going to get around 34.6 mu and then 11.6 mu. And so your map difference is going to be from V to SC to S. And between V and SC, it's 11.6, and then SC and S is 34.6. And then you're going to determine your interference value, and you should get about 44% for your interference value. Okay, so for 3, again, you do the same exact thing as you did for 1 and 2. You're going to determine the gene arrangement for the 3 linked genes, and you get C plus, S plus over C plus G, S. Oh, sorry, I missed a G in the numerator of that, when I was going over it. And then the order of the 3 linked genes are C, G plus, S plus, and C plus, G, and S. And for the linkage map, you're going to have your least amount, again, of offspring, and that's your 8 and your 11, and you're going to add that to the 2 offspring, I guess it would be 4, but the 2 separate offsprings that were just flipped once. And you'll notice that for the second one, which I think, I'm just going to go ahead and look at this real quick. There were no instances where it was C, G plus, and S, and no instances where it was C plus, G, and S plus. So because of that, you're going to have 8 plus 11 plus 0 plus 0, and that gives you 1.9 mu, because there's still a chance that it could happen, it just didn't happen in our offspring. And so then for the next one, we get 7.5 mu. And so then your map is going to look like C to 1.9 to G to the 7.5 to the S. And so to determine the interference value, you actually get 100%.